Okay, so welcome again, guys. Welcome to the class. About the recording, it's not 100%. I guarantee that there will be a recording every time, okay? Because it depends on the internet and also the technique problem. So the suggestion is that I suggest you guys attend the class regularly, all right? Let's continue. I want to help you guys with the Lagrangian multiplier method. So let's go through again. Remember that here is about utility maximization problem, right? So you need to know which one is the objective function, okay? Since we want to maximize the utility, so here is the objective function of us that we want to maximize. And we also need constraint, which is the income, the budget line, right? This is our constraint. And here I showed you how to take derivative if the function is a power function. So we need to use the power rule, okay? X power n. So the derivative of x is nx power n minus 1. I think you guys learned this one in your high school or when you take the mathematics class. And here I showed you the example, x power half. So we take derivative, that's gonna be half times x power half minus 1, right? So here we have 0.5 times x, and then here is negative 0.5. Here's the answer. So the first step, we need to write the Lagrangian function, okay? The idea is that we combine the objective function and the constraint into one equation by using lambda. You see here how we read this equation, objective function first, and then constraint second, okay? So here's how we write a Lagrangian function equation. And next step is that we take the first order conditions, right? FOCS, which means first order conditions. First order because we have three variables here, right? Because we have three variables here, which is x, y, and lambda. If we want to take the first order condition, that means we take the partial derivative, okay? Not total derivative, okay? Let me explain what is total and what is partial to you here. If we want to take the partial derivative, okay, partial derivative, the symbol is, look like this, okay, curly d, this is curly d, which means partial as well. We use it when we have function has two more variables, okay, we take partial. And next one is total derivative. Total derivative, we use the symbol d. That means if the function has only one variable, okay, we use total derivative. Okay, let me give you example. Suppose the utility function is if the utility function only has variable x, that means we need to use total derivative. But if the utility function has two variables, okay, like I showed you before in our example, which is x and y. So here we have two variables, right, x and y. That means if we want to take derivative, we need to take for each variable. So we're going to use partial derivative. So for partial, we use curly d, which is cur. And also because utility that we learned always depends on x and y, right? That means we're going to use partial derivative in consumer theory. Okay, so let's continue. So first order condition, we take partial derivative with respect to x, y, and lambda y, because those three are the variables that we want to find out, okay? It's unknown variables. And then we set each equal to 0. So here we have a first order FOC for x. Here is how we get it, right? If we take the first order condition for x, that means we're going to treat variable y and variable lambda as a constant, okay? Constant in mathematics just means they are numbers, okay? So assume that we know it. So here we have half times x negative half times y power half, and then minus lambda times px, okay? Because here, x, right? Negative px and times lambda, those are the parameters of x, because here we are taking the FOC of x, right? And then we set it equal 0. We arrange it like lambda, because when we want to find out lambda equal, so we isolate lambda to the left side, which equal half times x power negative half, y power half, divided by px, okay? Here gonna be our first equation. The same logic, we do the first order condition for y. So here we treat x and lambda as a constant. Here we have half times x power half, but y should be power negative half, right? And then we minus lambda times py equals 0. And then same logic, we isolate lambda, which is this equation, and then we name it as equation 2. The last variable, which is lambda, so we take first order condition for lambda, we have just this one, right? Just the budget constraint here, okay? So which is m minus px times x minus py times y. We set it equals 0, and then we rearrange it, okay? We move m to the right side. So here gonna be our third equation. This is the step 2. And the last time we finished here. So next one, let's solve the system. How to solve it? Last time I showed you. So we said equation 1 equal to equation 2, right? So let me erase those things. Okay, so let's go step by step. We set equation 1 equal equation 2 because both equal lambda, right? What do we have? Okay, here. Okay, equation 1 and equation 2. So we set them equal because they both of them equal lambda. We have 0.5 times x power negative half, y power half over price of x. Okay, here is equation 1. And equation 2 looks like this: 0.5 times x power 0.5, but y here power negative 0.5, okay, over py, okay? Here I just rewrite equation 1 and equation 2, okay? And then we cancel half on both sides, okay? Because we have here half here and half here, so we can cancel them. If we cancel them, we have x power negative half, y power half over px equal x power half, but y power negative half over py. Next one, we do the cross multiply. Okay, we do cross multiply. Cross multiply means we're gonna use numerator here times the denominator. Okay, we cross multiply. So we have py times x power negative half, y power half equal px times x power half, y power negative half, okay? Sounds a little messy, right? We have power half, power positive half, negative half. And then we want to simplify. How are we going to simplify? We're going to simplify this equation. So we're going to divide both sides by x power negative half and y power negative half. Okay, so here we are trying to simplify. So we divide both sides by x power negative half, y power negative half. Because of what? Because on the both sides, okay, we have here x power negative half and y power negative half. We want to cancel them out, okay? So that's why we divided both sides by this. And what do we have? So we're gonna have, let me write it down again. But I just copied. Divide, right? I need this one as well. Divide both sides, okay? Okay, now let's simplify. The left side, what do we have? We have py times y alone. It's okay about here. Why? Because here we have x, right? X power negative half over x power negative half. Actually here equal to x and then negative half minus negative half, right? Let me write it here. So here we have x negative half minus negative half. Okay, minus becomes positive, right? So next one, x negative half plus negative half. So here just cancel out, equal x power what? 0. X power 0 equal what? You learned from your high school. 0 or 1? 1. Exactly. So here we have 1. That means we canceled y out, right? But for y, sorry, we canceled x out. But for y here, so y gonna be, let me write it down. So y here, y it's power half. So y the same logic, gonna be minus power half. That means y here is half plus half, which is power 1. So here is y itself. That's why we have here py times y along here. The same logic for the right side, we have px times x along. So now I think you may know how we get this one, right? Let me help you with this. So here, let's see the first term, which is x. Okay, so x, I'm gonna write it here. X power half over x power negative half equals what? Equals x half minus negative half. Okay, minus half. That means which is positive. So here becomes half plus half equals x power 1. X power 1 means itself. Okay. Next part, y. Okay. Are you feel dizzy now? No. I hope not. Okay, next one. Y power negative half over y power negative half. Here, actually, because the numerator and the denominator, they are the same, right? So we just cancel them out, right? Which equal to 1. Or you can use the way that I showed you here. So here, y negative half minus negative half, which means negative half and the positive half, they're going to cancel out. Okay, so we have py times y equal px times x. And then we isolate y alone. So y equal px x over py, right? Here gonna be our equation 4. And this equation 4 is exactly our MRS condition, okay? Marginal rate of substitution. At the optimal. This means that spending on X equals spending on Y, okay? And next one, we're gonna substitute equation 4 into budget constraint into equation 3. Where is equation 3? Here. Okay, here is equation 3. We're gonna substitute equation 4, which is y equal. So we're gonna replace y here. And I'm gonna copy this one. Because this is our equation 3. Copy it. This is our equation 3. And then, because equation 4 is about y equal what, right? So here, y, I'm gonna replace y here, okay? Okay, what do we have? P x times x plus py time y, but y here I'm gonna replace by px over px, sorry, px over py times x and equal the income. Okay, equal the income that you have. Simplify it. Here we can cancel py. Okay, so next one, px times x plus px, okay, times x is here, equal m. That means 2pxx equal m, right? And then we solve x. So here, because here is our unknown, the one that we want to find out. So x star equal m over 2px, which means this one, x star, is our demand function for goods x. Right? So I use star to represent this is our answer, demand function. And since we get x star, and now I'm gonna substitute x star into equation 4, right? Because as this is x, I'm gonna substitute x star here, and then I'm gonna get y star, right? Okay, so substitute this one back into equation 4. What do we have? So here we will get y star equal price of x over price of y times m over 2px, okay? Because here is x. This is x, right? This is our x star. So here we equal what? You can cancel out px, right? We can cancel out px. So we have m over 2py. Okay, that means y star equal m over 2py. This is our demand function for y. Clear about those two? Okay, so right now we find the demand function of x and y. And the question said that suppose price of x equal 1, price of y equal 2, and the income equal 100. We need to find the optimal consumption bundle. That means we just plug numbers, right, into those demand functions, x and y, and then we're gonna get the optimal consumption bundle, okay? Next one, so now let's plug in numbers. What do we have? Price of x equal 1, price of y equal 2, income equal 100. Okay, so let's plug in x star equal 100 over 2 times 1, okay, equal 50. You just plug numbers into x star and y star, you will get the answer, okay? Same idea, y star equal 100 over 2 times price of y, which is 2 here. So here is 25. Okay, so here those x and y are optimal bundles, okay? Equal x equal 50, y equal 25. Let's do the spending checking, okay? Let's do the spending checking. Because our budget constraint is px times x plus py times y equal, so let's plug number. Price of x is 1 and x will have 50 plus price of y is 2 and the amount of y that is 25. Here equal what? Equal 100. Exactly our income, right? That means this is correct. Next question, find MRS. Still remember the formula of MRS? Find MRS. In general, MRS XY, okay? So MRS XY. What is the formula? Still remember? It's the ratio of the marginal utility, okay? Which means MU, marginal utility you get from X, and marginal utility you get from Y. Because our utility function is X power half, Y power half, right? So here, how you gonna find MRX? Okay, you take partial derivative. Okay, first you take partial derivative with respect to X, and then you get MUX. Then you take partial derivative respect to Y, okay? Actually, the same thing here that we did for the first order condition, okay? Here. Okay, let's do it again. So we're gonna take the derivative respect to X. That means I treat Y as a constant. So here is 0.5 X, but power negative 0.5. Why you treat it as constant, okay? This is MUX. Let's see MUY. MUY, you treat X power half as constant, and then you do it, take derivative, which is half times Y power negative half, okay? And here is, we can cancel half. 4x is negative half minus negative half times y. Y is half minus half. Okay? Okay, that means for x, the power is negative 1. And for y, the power is positive 1, right? 1 is negative, 1 is positive. And you also know that if x has power negative 1, we can write it in the denominator, okay? So here x gonna be in the denominator, which is x. And then y gonna be the numerator. Okay, this is our MRS, okay? MRS. And we also know that at optimal x star equal 50, y star equal 25. So now MRS also equal, so we plug it in y over x, which means 25 over 50, which is 1 over 2. 1 over 2, and then we also know the price ratio, right? This is the price ratio. Let me copy it. So 1 over 2 is also the price ratio. Equal price of x over price of y equal 1 over 2, okay? We check, we double check, and it's correct. This means MRS equals price ratio. And this is the optimal consumption, optimal condition, confirmed. Okay, I'll give you several minutes to digest what we've going so far. Next question, find the maximum level of utility that consumer can get. Maximum utility, so U star equal X star power half, Y star power half. And then we plug in the numbers, right? X star is 50 power half times Y star, which is 25 power half. So here is square root 50 times square root 25 equals 5 times square root 25, and then approximately equals to 35.36, okay? For the square root, you can use the calculator. The calculator is allowed for the exam. Okay, next thing, what is the unit of utility? It's the util, okay, util. UTIL, okay, util, because it's more than one, so it's utils here. So the unit of utility equals util. The next question, find the marginal utility of income, okay, which means num down, okay? Num down means the marginal utility of income. Marginal utility of income. This is the meaning of lambda, okay? Lambda is the marginal utility of income. So we plug x star equal 50, y star equal 25, into equation 1. What is equation 1? Here is equation 1, right? I can copy it, paste here. So that means (0.5) times 50 power negative half. You just plug number in, and 25 power half over 1. And here becomes 0.5 times square root 25 over square root 50. Okay? Because 50 power negative, so 50 gonna be in the denominator, right? And 25 power positive half, so 25 gonna be in the numerator. Okay, be careful about those. And then you use your calculator. Can you use your calculator and find out what is lambda? Okay, so approximately lambda equals to 0.354. Okay, here is the answer for lambda. As well, utils. What does lambda mean? What does it mean? It means if your income M increases by 1 baht. Increases by 1 baht. Your maximum utility increases by, okay? This is how we explain lambda, and also you're gonna use this logic when you learn econometrics. If your income increases by 1 baht, your maximum utility increases by 0.354 units, okay? Here is the meaning of lambda. And another thing is, because lambda equal marginal utility of income, right? Let me copy this one. Because lambda equal marginal utility of income, this connect back to the equal marginal principle, okay? Equal marginal principle, which means that we use the marginal utility over the price of that good equal the marginal utility from y over the price of y, which is lambda. Okay, it means that how much happier you get from 1 more baht. Okay, how much happier you get from 1 more baht. Okay, the last step, remember, we have 4 steps for the Lagrangian. Next step, step 4. check second order conditions, okay? Check second order conditions. What is second order condition? And why do we need it? Because as you may know, first order conditions just find where the slope equals 0, right? Because we take the derivative and set it to 0. First order condition just find whether the slope equals 0. But it could be a maximum or minimum or a saddle point. That's why we need second order conditions to confirm is it truly a maximum. Because here we maximize our utility, okay? Because here is a utility maximization problem, okay? So second order conditions confirms is this truly a maximum? Let me show you the graph, okay? We have this one which is concave. We have this situation which is convex. We're gonna have this one. If it's concave like this is concave, right? Concave means curve bends down. So it means it's a peak. Okay, just like here, it's a peak. First order condition find that here we're gonna find, okay, so here means slope equals 0. And because here is concave, that means this point here is the maximum, right? And we need to check that if the second order condition double prime is less than 0, that means this is a maximum. Another case, if the curve is convex, okay, this one is convex. Remember, indifference curve looks like this, right? Indifference curve is convex as well, that we learned before. So if a function is convex, that means we can find a point, okay? The same idea here means slope equals 0. And if it's a convex, we can be very sure that this point is the minimum, okay? And for the second order condition, we need u double prime greater than 0, okay? We can find the minimum. Another case, like this shape, it increase and then decrease the slope. So here, what happened? So if we take first order condition, it just tells us the slope here equals 0. But it's not a maximum or minimum, okay? It's ambiguous. It's ambiguous. So in this case, the second order condition, u double prime equals 0. We don't know, okay? Because here is a saddle point. Okay. Okay, so because our utility function, see this one, u equal x power half, y power half. Here is a Cobb-Douglas utility function. Have you heard this before? Cobb-Douglas utility function. And its strictly concave. Okay, for Cobb-Douglas utility function, it's strictly concave, which means look like this. That means there's only unique maximum, okay? And also we can do the second order condition check as well. So here, from method 1, we know that this utility function is a Cobb-Douglas utility function, which is strictly concave. So there's only maximum. Another method is that we take the first derivative. Okay, we take first derivative respect to x, 0.5 x power negative half, y power positive half, and then we take the derivative one more time. Okay, this is second order condition. So here is 0.5 times here, right? Because we only take derivative with respect to x. So right now here is negative 0.5 times x. Here, x gonna be negative 5 minus 1, okay? Times y power half. So here we have negative 0.25 x power negative 1.5, okay? So here is negative 1.5, right? And y is 0.5. Okay, so let's check the sign. Because x and y are the goods that we bought, that we consume. So it's always positive, right? It's always positive. Because x is greater than 0, y is greater than 0. Because this is the quantity that we're going to consume, okay? So here we have, so that means this one is positive. Here is also positive. Positive times positive, positive as well, but we have negative 0.25 at the front, okay? This is negative. So finally, our second order condition gonna be negative, okay? So this confirms that it's what, okay? It's a maximum. Let me show you the summary table. Okay, so let's see, X star, Y star, U star, MRS, and also lambda. What is X star? What is the formula? M over 2px, and the value is 50 units. For Y, the formula is M over 2py, which is 25 units. For the maximum utility, we have, what is the formula? X star power half, Y star power half, right? And approximately the value is 35.36, okay, joules. Don't forget the units. And next one, MRS, what is the formula? You can review later, okay? Y over X, this is the formula. And the value is 1/2. And exactly the price ratio, price of X over price of Y. How about the lambda? The formula is MUX, marginal utility of X over PX. And the value is approximately around 0.354 joules per watt, okay? So Lagrangian method equals merge utility and budget into one equation. And then we differentiate 3 times. We solve it. And then you find exactly how much to buy and how happy you will be. Okay, this is the logic of Lagrangian methods. Okay. And next class, I'm gonna show you another method, okay? Because here we talk about utility maximization, utility maximization problem, okay? Next class, I'm gonna show you another method, which is the MRS method. You will find that actually MRS and the Lagrangian methods are quite the same, but MRS method is the intuitive, okay? It's more intuitive. It's faster for simple problems, and it shows you why the tangency condition works, okay? For the MRS method, let me show you. Because we have 2 goods, right? X and Y. So we have budget line. This is budget line. This is budget constraint. And we want to maximize utility, right? The utility is on IC curve, right? This is our indifference curve, okay? So as long as IC is tangent, IC tangent to the budget line, so here gonna be our optimal. Okay? So this is the intuitive logic of MRS method, but I don't have time to cover it today. I think today it's enough about the Lagrangian methods. Okay, so here gonna be your homework, Lagrangian multiplier methods. I'll post it on Canvas later. The same logic, okay, but different utility. So here, please use Lagrangian multiplier method to do it. And also, I want you to think about, can we use the Lagrangian multiplier method with the following cases? Can we use Lagrangian to solve perfect substitutes and perfect complements? Yes or not? I hope you can find out and we'll discuss it later. So that's all for today. Do you have any question about today's class? It's quite heavy math, so I hope you can review it, okay, later. I'm gonna upload my slides and with the note to the Canvas, okay? Please review it. This is very important, okay? If no question, I'll see you next Monday, right? I'll see you next Monday. And please review chapter 3 because we barely finished. We're gonna have the in-class quiz next Monday, okay? So no question. Thanks for coming and see you next time. Uh-huh. It's okay. It's okay. I just checked on this now. Yeah, it should be fine.
This part is so difficult.
It's so difficult? No.
After this chapter is more difficult.
No. It's all the same. We're gonna learn Lagrangian as well in next chapter.
Can you still send your homework next Monday?
Sure. Actually, yes, this one and also the new homework. Okay.
I forgot to pen.
Oh, okay, let me see it. You use MRS, right? This is easy method. Can you understand the Lagrangian? Okay, so please review it. Where is your other friends, the Thai boys? They are not? They are not coming for today because of the white group. But I said I don't have class. Sorry?
I can't see it.
Canvas. Can you see it? It's on Canvas.
And I did not finish it.
Oh, okay. So submit to me next time. I'm gonna post on Canvas. Okay, you just submit it through it.
I can submit in Canva.
Yes, but later. I'm gonna post it later. Okay? So see you next Monday. It's okay. Yeah, but you're gonna have a new homework, the real homework. A lot of information today. How are you feel? How do you feel? Good. Okay. Oh. Yes. In class quiz, but it's just multiple choice. Okay. Bye. Next time. Yeah. Give it to me next time. Yes, the new homework. Okay. ขอบคุณค่ะ Bye bye.